What's up friends, today we are here with another part of the Black Mamba series, but this one is a bit more useful for people that aren't necessarily building a DIY board like this, but instead building a regular DIY board. Today we're going to be doing the VESC tool configuration for the MakerX D75, which will also apply to the D100S, the DV6S, DV6 Pro, and the DV4S. So stay tuned if you want to figure out how to configure a VESC for DIY. All right, so the first thing you have to do when getting into DIY VESC programming, especially for Esk8, is actually acquire the tool to program it. So first off, you're going to need to get VESC tool, and there's two options. One is a mobile app, and the other is the PC app. Now, both are completely capable of programming every aspect of your VESC, but for me, I find that the PC one makes more sense, and I'm just more used to using it. The mobile one works fine. There are some ways that you can mess up your programming if you're not careful, but overall, I like PC better. So let's go ahead and get that right now. All right, so to get VESC tool, all you really have to do is Google VESC tool and then click on the first link, which will take you to VESC project. And you're going to have to create an account for this in order to download the VESC tool software, which is fine. It is free, but you do have to make an account. So we're going to go ahead and log in with my account. All right, now that we're logged in, we're just going to go ahead to VESC tool, the tab in the header, and we're going to go to VESC tool free. If you want to donate to VESC project, I'm sure Benjamin Vetter and them would be happy, but for me, I'm not going to. Now, you don't have to fill out any of this information since you're just getting the free. And click submit order. So it's going to send you a confirmation email with a link to it, but we're just going to go to purchased files. And then all you have to do is download for your appropriate version. And for me, I've downloaded it 10 times, and today on purchase, that was the first time, whatever. Anyway, we're just gonna click VESC tool free, save that. And VESC tool is interesting because it doesn't install as like a program per se, so all you really need to do is unzip it and then place it in the folder that you want to. So we're going to go ahead, place it in that folder, and then I'll go ahead and open it up and we'll start on the first step. All right, so we have got VESC tool opened up and ready to go. So right here on the front screen is where you're going to be for most of your setup. First of all, you need to either plug your VESC into your computer using a USB tool, a micro USB cable or USB-C cable, depending on which ESC you have. And for me, I'm going to be doing it slightly different. So in this video, I will not be using the cable. I'm going to be trying to program it all through a wireless connection with the VESC tool app. Now, right now I'm going to go ahead and turn on my board, which happens to have a Metr Pro and a Robogochi Pro, which is a beta product. But right here you can see, if it'll focus, please, you can see the two devices. So what I'm going to do is I'm just going to go ahead and hit connect on Black Mamba, which is what I named that Metr Pro. And we're going to go ahead and use a special thing called the TC bridge, which will allow you to connect it to your computer. Let's go to manual focus here so we can look at this properly. So right here, we're going to use the wireless computer bridge, and we're just going to go ahead and hit activate bridge. And now you can see it popped up on my computer here. So that is how we're going to do that. I'm going to make sure that my phone stays nice and close to the board to make sure that we don't lose connection, but we're just going to go ahead and hit connect. And there you go. So this is something that you see a lot in VESC tool, saying that the VESC has old but mostly compatible firmware. Now this is mostly an error message just to notify you that you can update your firmware. This does not mean that you have to update it, and most of the time you don't need to update your firmware from the factory because it'll either be on the latest or one before the latest, and most of the VESC firmware nowadays is pretty stable, so you don't have to update if you don't want to. Now, first thing I like to do is turn on real-time data and real-time app data, as well as, I guess that's all I need for now. But that will allow me to see my battery percentage and my temperatures, and also my input from my remote by default. Now, what we're going to do first is we're going to just go ahead and set up motors FOC. Now, this is going to go through your motor detection for your ESC and your motors. I don't ever want to write default settings because default settings are nowhere close to accurate, and might as well just start with whatever you have on there. Since we're programming an Esk8, we're going to hit the Esk8 button and we're going to hit override. This duty cycle current limit start is very important for Esk8 because it allows the current at the top of your acceleration range to slowly die out instead of cutting out and making you fall off your board. So make sure you check that when you're programming your ESC. Now, for my particular motors, I have 6374 motors from Flipsky, and we're going to select the medium outrunner. You may be able to select the large outrunner, but I found that medium outrunner works just fine, and we're going to be changing the motor amps settings anyway. You don't have to hit override here. I'm going to go ahead and hit next. Just agree to this because we know that our motors are big enough to take the amps. Now, this is where you're going to set up your battery information. The series cells is very important because it's going to determine the base numbers that it sets for the voltage in your ESC. So we're going to go ahead and set that at 14 since we're on a 14S battery. And our capacity is going to be the amp hours of each cell times your P groups. So for multi-cell P482A, it's about 4.2 amp hours per cell times 6, which is going to be 24.8 or something like that. Right? Am I doing that right? 25.2. Whatever, close enough. So we're just going to set this at 25 amp hours. This part is not as important, but it's good to just put in there. Now, battery current regen and battery current max. This is what your ESC is going to request out of your battery. So if you have a battery max discharge number from your battery maker, this is where you're going to put that in battery current max, but you're going to divide it by 2 because this is per side of the ESC unless you're using a storm core. So for this particular battery, we can give it all the beans because I know that it is capable of providing up to about 30 amps times 6, 180 amps, no problem. So we're just going to set this to 50 amps max per side just to start. I might turn it up in the future. Battery current regen is how much your ESC will send back into your battery when you're braking hard, and I like to set this at a nice reasonable value of -15 per side of the ESC. That's going to be putting 30 amps max back into my battery for short periods of time under that max braking circumstance. If your battery is smaller in P groups, like a 2P battery, you don't really want to be putting 30 amps back into it, so you want to be careful. While it is a small amount of time, it can stress the cells out a little bit more, so I might turn that down if my battery was smaller. Wheel diameter, you're just going to set to your wheel diameter. Mine are 165 millimeters. Oh, 175, forgot these are 7-inch tires. And then you're going to set your gear ratio here, and this is going to tell the VESC how fast you're going. So make sure you get this right. If you get it wrong, you're going to end up with inaccurate speed values when you're looking at your data in your telemetry devices if you have them, or if you're in the VESC tool app and doing logging there. Motor poles, most of our Esk8 motors do have 14 motor poles, aka 7 motor pole pairs, so don't have to touch that. And then we're just going to hit the run detection button. Now what this is going to do is it's going to slowly spin up both motors, one on each side of your ESC, and it's going to make some weird noises, but don't worry about it, it'll be okay. As long as there's nothing obstructing the wheels or your drivetrain, you should be fine. You may hear this on the microphone. It's gonna be like a little squeaking sound, and then the motors will turn slowly to detect the Hall sensors at the end. So we're gonna let that do its thing real quick. A little click at the end usually means it's done. Now we should see 2 motors detected successfully with their Hall sensors and their detection values. It's taken a little bit longer than normal to process. All right, well, we ran into our first fun VESC tool issue, and this is an annoying one. Basically, some of the new versions of VESC tool don't let you detect your motors unless you're on the latest version, or it says that, and then sometimes it'll process and it'll still write it. So let's see what happens here. I do happen to have the old version of VESC tool for the version of the firmware that's on my ESC right now. And yeah, it says success, but it only did 1, and that's just not correct. So we're going to go back to the beginning, cancel that, and then we're going to go in firmware just to show you guys what version I'm on. And it's still confused there. So we're on version 5.3, which is the latest supported version for the Robogochi Pro. So I don't want to update my ESC to the latest firmware. So we're gonna have to use an old version of VESC tool. And I happen to have it on hand, but most people might not. So real quick, I'll show you how to update your firmware if you need to update it. So updating firmware on MakerX ESCs must follow a very strict process in my experience. 1, you really should use the cable, which I'm not going to use right now because I'm not updating it and I don't want to open my board. The cable helps a lot to make sure everything goes smoothly. And 2, you must flash Bootloader to each ESC individually before trying to update the firmware. Now, what that means is we go over to the Bootloader tab and you just flash the generic Bootloader. You click the download or update firmware on connected VESC button instead of all, because all just doesn't work for some reason. So you plug into your first ESC, flash the bootloader just like this, press that button right there, and then you're going to go over to your firmware tab, and it's going to automatically know which hardware and firmware version you're on. So you should be able to just click the download, upload firmware on this connected VESC. You're going to do that, and you're going to wait for it to reboot on its own. You'll see the lights on the VESC turn off, and then they'll turn back on probably within 10 to 20 seconds. And once you're able to reconnect to the VESC, you'll know that it's updated. And then what you're going to do is you're going to hit disconnect. You're going to move your cable to the other side of the ESC, and then you'll do the same thing. Flash bootloader, and then download the firmware, and that should end up with a fully successful firmware update without having any weird motor config issues later, which is something that I have had a problem with in the past. So make sure you do bootloader and then firmware for each side. If you want to upload the custom firmware from the MakerX website, you can do so through this tab, and it's just going to be the same process. Make sure you flash the bootloader. All right, so I'm probably going to chapter this part of the video, but this is why I don't like trying to use TCP bridge and the mobile tool, because look at this. I did that attempted motor detection, and now we go to try and connect on here, and it just says read firmware version. Like, what the heck is that supposed to mean? I wish sometimes that VESC were more developed, but here we are. So basically I'm going to have to open up my board and plug in via the cables like I was telling you guys to do. So let's do that now. All right, so I've gone ahead and opened up the board. It is in the background here, as you can see, and we're just going to turn it on. Plug into the USB, and we're going to configure it the old-fashioned way. So now we're in VESC tool, we can just hit connect and it will just work. So now we can use the auto connect and it will connect to the ESC. Now we are still in the old version of VESC tool because I just don't feel like messing with the new one. But for kicks, let's go ahead and just try and see if the new one will connect. Probably will. We probably should use the latest version, but I don't know if it's gonna let us. So I'm gonna speed run this since you already saw it the first time. No defaults over beyond 14.5, 15, 50, 5, 16, 68. Okay, now when you touch it, try this time. Watch the LC right here. We're bouncing on my quad side. Right now we're taking pulsators. Click. Let's see if we can link this time. Let's see if I can do the ESC. Well, apparently it just really hated the TCP bridge. So if you don't use that, you'll probably be okay. It looks like we detected at 58 and 59 amps, which is pretty low. We'll be able to change that. So now you want to check your orientation. Forwards is correct on that one, and forwards is correct on that one. So we're all good, and we can hit finish and it will write all the settings to your ESC. Now hopefully that wasn't too quick for you and it all made sense, but I don't want to make this video an hour long. So there's your motor detection. Now we did lose the real-time app data here, so we'll turn that back on just for information. And now, since we have our motor set up, we can go ahead and mess with some settings, but I like to set up the input first. So we're gonna go ahead and set up input. Now, this is gonna be only necessary if you're using a remote that is using a PPM signal, which I do recommend using that because the Hoyt Puck is one of the most reliable remotes and that uses a PPM signal. So you'll probably need to do this for your setup. If you're using a remote on UART mode, you won't need to because it will just work automatically, which is fairly nice as long as it's working. So I am using the Zmote. I don't recommend this one quite yet because it has had some issues, but that's the one I'm using right now. It is a PPM remote. So when we go ahead and move the triggers here, it's going to set our max and min, and for a puck it's going to be very similar. You're just going to take it and you'll have your max and min and it'll show up the same way. So don't worry about that. So we got max 1.95, min 1.06, center at about 5.03-ish, and then we're gonna hit apply. It's important to remember to hit apply. Deadband, I think I'm going to turn down to 10%. It's a little different for dual trigger remotes like this than it is for the puck. The puck, I would recommend setting deadband at about 7% or 6%. Now, this is where we're going to set our control setting, and what I'm going to do for this particular setup is go into current mode. We're going to set up reverse in a different way than normal. But for most people, you'll probably want to use current smart reverse, and that will give you that nice slow reverse after you hold down the brake trigger. So for me, we're going to go in current mode. Not going to turn on traction control, and we're going to turn down our positive ramping time to 0.2 seconds, and this makes it a little bit more responsive. You may find that you like that, you may not, but that's something that I usually set. Now, we have to make sure we hit right configuration to VESC, otherwise it might not write. Just a thing that you have to remember. And then you can hit done. And now what's going to happen is when I pull the trigger, the wheels will move. And right there, you could theoretically stop, but you might have some issues down the road because VESC tool does a fairly good job at setting most of your settings according to what you need, but we're going to go ahead into some custom tuning now. And if you guys have seen the old video that I had, the DV6 one, we did some custom tuning there too. So for most people, I recommend you stay and watch this part. If you really need to be done, technically the settings that are in there right now from what the setup is that we just did will work for most people, but I'm going to explain in this part why they might not be the best for you and why I'm changing the settings that I'm going to change. All right, so it's time for some custom setup. Now, what we're going to do here is go into some different tabs and make sure that all of our settings are to our liking. One of the things to do in VESC tool is to always remember to click Read App Configuration and Read Motor Configuration, especially when you're switching between the sides of the ESC, which is something that we're going to have to do right now. First off, we're going to go into motor settings in general, and you can see your motor control type, and what we're going to do is change our current. Now this is the motor current, how much current the ESC will send to the motor while you're accelerating. And I'm going to go ahead and bump this all the way up to 100 because I know that this ESC can do 140 amps, but I'm going to start at 100 and then later I'll bump it up. Absolute maximum current, you don't want to touch that. That's something that should be set by the ESC. And if you set that too low, you can get thrown off your board. So don't mess with that unless you need to. But I do like to turn on slow ABS current limit, which gives it a little bit more leeway before it cuts off power. Battery current max and battery current max regen we already set during the setup, so we don't have to touch those. For voltage cutoff, I do like to change this a little bit. So what we're going to do is we're going to use the calculator, and we're going to set this to 3.2 cutoff start, so 3.2 volts times 14S, that's your voltage, or my voltage. And we're going to set the start to 44.8 volts. And then we're going to set the end to 3.0 times 14, which is 42. So that one's already set. I just like to set the cutoff start a little bit higher, so I get a little more power for a little longer. Now, we've set all these settings in here, and we're going to go ahead and change one other important thing that a lot of people miss, and that is fault stop time. Basically, if you encounter an overcurrent error or another fault, the VESC will typically try to restart, and it'll restart the processes. This fault stop time is how long it will stay off before it tries to continue what it's doing. And at 500 milliseconds, which is half a second, you're really going to feel it, and it can throw you off your board. So most of the builders and myself like to set this to about 50 milliseconds to make it a little bit more safe for if your board is to get an overcurrent fault. Now, all of this is set. We have to remember to click Write Motor Configuration, and this is only for the side of the ESC that you're currently plugged into. So we got Write Motor Configuration. It is now written to the board. Now, this side is also the side that my PPM remote is plugged into. So we can go in here and we can change a little bit about that. And we're going to change this to be a 7% polynomial curve, and that's going to give me a little bit more punch in the low end. And throttle mapping is fine. Now, there's one thing that I do want to change. I need to go look at my friend's settings to do this. But basically, since we're in current mode, that means as soon as you press on the reverse or on the brake button, it's going to take you all the way to stop, and then it'll send you back in the other direction. And that's a setup that some people might not like, but that's what I'm going to do for this particular board. So we're going to go ahead and look at those settings, and I'll be right back. All right, so I'm going to try to quickly explain the difference between smart reverse and full current. So smart reverse, basically, you brake, you get all the way to 0, and then it'll wait the amount of time that it says in your smart reverse ramp time, and then it will start going in reverse up to the max duty cycle that you set in smart reverse max duty cycle. Now, there's one way to get reverse. The way that I'm using to get reverse in this particular setup is going to be through full current mode and a ERPM limit in the reverse direction. Now, ERPM limits can be dangerous in the forward direction, because if you pass it, you won't have any brakes, but we're not going to have that problem in reverse, so I'm not too worried about that part. Now, for The reverse max ERPM, we're going to go into the RPM tab in the motor section, and max ERPM 100,000, way above what I'm ever going to hit, but in reverse we can go ahead and set this to negative 10,000, and this is going to give us a decent speed in reverse, but still give us a lot more braking performance potential than if it was just braking alone. So I'm going to go ahead and write this in the motor settings. Remember, this is only per side, so before we try to test this on the board, I'm going to go ahead and switch to the other side. And the way to do that is by clicking this CAN forwarding button, or by clicking in the other CAN device in your window in the bottom here. So we're going to hit CAN forward, and now this is very important. Remember to click read settings, read app, read motor. I wish that did that automatically. It doesn't. Maybe it will do that in a future version of the tool. So now you can see that obviously our max ERPM reverse is reset because we're on the other side of the ESC now. So we're going to go through and set the same settings that we did on the other one. 100, minus 100, oops. Set this to true. We're going to leave those as is. Voltage, we're going to set this to 44.8. RPM, negative 10,000. We don't have to mess with anything in these tabs except for the fault time, which we're going to turn down to 50 milliseconds. Now, that should be everything for the motor, so we're going to hit right. And then we're going to go in here into VESC remote, because for some reason it's in here. I don't know if you have to do this, but I'm going to go ahead and set this to 7% on this side as well. I think when you use a PPM remote, it just forwards the information from one ESC to the other, so probably not necessary. But that should be pretty much everything that we need to custom set. And let's see how this reverse function works. So I'm going to turn my remote on. Now we've got full speed in the forward direction, and then if we go in reverse, we're only going up to that speed, which is great because you don't really need to go a whole lot faster than that in reverse. Now it does feel a little bit weird on the bench, but bench testing VESC is kind of inaccurate to compare to real world. So if you see something weird on the bench, it's not necessarily always going to show up in real life, but for this, that looks like a really great speed. So I'm pretty excited to try that out and see how that works. All right, so that is pretty much all of the information you need to know about VESC setup. It's not going to vary too much between your ESCs. Make sure you do the read function on the right side of the screen before changing any settings after you switch ESCs. Make sure you hit the right function after you change settings, otherwise they're not going to stick. Using the cable is usually the most surefire way to make sure everything goes properly. As you saw at the beginning of the video, the TCP link did not work properly. People like the mobile VESC tool. I'm not going to do a tutorial for that at this time, but maybe in the future. The only final note I have to make is about MakerX ESCs specifically. So for these ESCs, they have a power switch. Now, they are slightly different on each ESC that it's on. We have one on the DV6 Pro, we have one on the DV6S, the DV4S, the D100S, the D60, the D75. I think that's it. But basically, let's go through what to do for the switch real quick because it is kind of important. So there is actually a web page that shows you how to do this on the MakerX website, and you can go ahead and see that right there. So I will put that link on screen or in the description or something. But basically, the side of your ESC that has the switch on it is the master side, and then the other side is the secondary side. So on the side of the left ESC, you're going to make sure that it's set to always on. And on the side with the button, you're going to set it to off after 30 minutes. So basically, my ESC has already powered off due to the auto shutdown function. So I don't know why it's so short for this ESC, but it is. So we're gonna go ahead and reconnect. And now we're gonna hit read. And now we're going to go from our welcome, we're gonna go down to the general app tab. And and that's where you're going to find this setting. So right now we're plugged into the switch side of the ESC, which has the setting off after 30 minutes. And that is correct because I have not updated the firmware. Often when you update the firmware, it will overwrite the setting. So we're going to switch to the CAN ESC. We're going to hit read. This one also says off. My camera overheated, so I'm going to try to finish this quick. But basically, the other side is also set to off after 30 minutes right now. I think that's just because mine is a first batch and it's on the 5.3 firmware. But for people on the 6.2 firmware, make sure you set your other side of your ESC, the left side, aka non-switch side, to always on as the tutorial says. Otherwise, it might not function properly. And I wasn't recording the screen, but as you can see here, it's set to off after 30 minutes, and that's even after reading the ESC. So I think that's just specific to mine. Follow the tutorial setup for your ESCs of the newer version. My D75, for the record, is the very first batch, and it was a little bit different than the following batches. And now the D75 isn't even manufactured anymore. So hopefully you guys found this useful and informative. Please let me know if you have any comments down in the description below, or sorry, down in the comments below. And yeah, this will be my VESC guide for this year.